Have you ever wondered how weather stations and smart environment monitor system measure temperature and humidity in the real time? Today, we are going to build a temperature and humidity monitoring system using Arduino that continuously tracks the environmental conditions and display the live data. Temperature and humidity monitoring system uses a DST11 sensor to measure environmental conditions and display real-time readings on the LCD screen. This project demonstrates how smart monitoring systems collect and display important environmental data used in homes, industries, agriculture, and weather stations. Now, let's explore what's inside this RoboXCraft kit. In this RoboXCraft kit, at the top, you will see some goodies with stickers. Then you will get the battery holder with lithium-ion batteries. After, you will get a LCD display. In this display, it will show the readings of the real or live data of the weather conditions, which is sent by the microcontroller as a signal. And here are jumper wire for the connections of the components with the breadboard. Here you will get the breadboard for doing the connections, and here is the switch. Also in this RoboXCraft kit you will get this Arduino Uno cable to transfer the code into this microcontroller Arduino Uno. This microcontroller is one of the best microcontroller in which we connect all the components where it receives the signals or from the sensors and show outputs in the different components. Here there is one temperature and humidity sensor. It continuously takes the reading of the temperature and the humidity of the environment and sends signals to this Arduino Uno microcontroller to show the output in the LCD display. Now today we are going to make the project of measuring temperature and humidity with the DST11 sensor. First of all, start with the Arduino Uno and the breadboard. We are going to, this is the breadboard and this is the positive rail of the breadboard and this is the negative rail of the breadboard. If we give power at single point of the breadboard, then this all rail carries the same voltage of the power, and this is the negative one. In order to connect or give power to this breadboard from the Arduino Uno, we need mil-to-mil jumper wire. Here we have got this part, 2 mil-to-mil jumper wire. This is the Arduino Uno as a microcontroller. It has diagonal pins, analog pins, or these are the got this part. Here we have the Arduino Uno. These are the digital pins from 0 to 13. These are the analog pin from A0 to A5, and we have here VIN, GND, 5 volt, 3.3 volt. Most of the sensors works under the voltage of 5 volt, and VIN is for powering this Arduino Uno. We can power this Arduino Uno through this port or VIN point. Actually this VIN and this port supports the power of maximum of 12 voltage. So we can feed this Arduino Uno maximum of 12 voltage, or this 12 voltage is the safe limit. And if we feed power from the VIN or this port, we will get the constant 5 volt or stable 5 volt from this 5 volt port and stable 3.3 volt from this 3.3 volt, and these are very safe to power the sensors. And these are the digital pin and these are the analog pin. Like this digital pin shows the values of 0 and 1, or let's say this port are for turn on and off only, but this analog pins is like not only turning on and off, like it shows the values from 0 to 1024 like that, but this shows the values of 0 and 1 only. Now we are going to connect this red to the 5 volt and the brown one to the GND. Now the red will be connected with the positive rail, and the brown will be connected to the negative rail. Here you can see. Now what you can consider is this. Now this whole lane carries the positive 5 volt, and this another rail carries the negative. Now here we have battery holder, and here is the switch attached with this battery holder. You can attach it. Now here we can use 2 batteries. Here we can place the 2 lithium ion batteries, and the voltage goes above 7 voltage, and if there is 7 volt or more than 5 volt, we have to put this positive of these batteries to the VIN and the negative of these batteries to the GND. Like this. And be sure the switch is off, and as well as this is the symbol of switched off, and don't put the battery right now. Now we are going to add the major components. First of all, we are going to connect this temperature and humidity sensor DST11. Actually, this sensor measures the temperature from 0 to 50 degrees Celsius, also the humidity of 20% to 99% RH. It sends the reading to the Arduino through the signal pin. Here you can see 3 pins. This is the VCC, GND and DAT, that means data pin. Through this data pin, it sends signals to the Arduino Uno. In order to connect this sensor, we need 3 male to female wire. Here we have 3 male to female wire. We are going to connect this male to female wire with this, and this sensor works under the voltage of 5 volt, and as I already told, this is the 5 volt rail. So I'm going to connect this sensor with this, and this totally white one is the GND, so we are connecting it with the ground rail up in the breadboard, and this is the data pin. So to this data pin we are going to connect with D2. This is D0, D1, D2, like that. Now in order to show through this data pin, Arduino Uno will get the data of how much temperature is there in the surrounding, how much humidity is there in the surrounding, and in order to show the output, now we are going to connect this 16x2 12C LCD display. This display shows the temperature and the humidity in this screen. Actually the output whatever or the data whatever sent to the Arduino Uno, that will be calculated by the Arduino Uno, and as the output Arduino Uno sends that data to this 12C LCD display, and this LCD display use only 4 pins, that is GND, VCC, SDA and SCL. As you can see in the display, in the screen you can see it. Now we are going to connect this display. Here in order to connect this display, again we need 4 male to female wires. Here we have 4 male to female wire. We are going to connect this male to female wire like this. Here the VCC will be connected to the again positive 5 volt rail. This is the positive 5 volt rail, and this red one is the GND here, and the GND will be connected to the negative rail in the breadboard. And here you can see SDA. This yellow one is SDA. You can see the yellow pin is SDA. The SDA will be connected to the A4 analog pin, that is A4. And SCL will be connected with the A5 pin. Now we have done all the connections. Now here you can see we have 2 lithium ion batteries. Now we are going to use these 2 lithium ion batteries here. As I have already shown, the switch is off. Here, before uploading the code, we are going to test. Here we have placed the battery. Now I'm going to turn on the switch. Before uploading the code, we are checking whether the Arduino Uno is getting power or not. Yes, the Arduino Uno is getting power. Now we are going to upload the code. Here, this is the Arduino Uno cable. We need the Arduino IDE software in order to upload the code in this sensor, in this microcontroller. Here we are going to put this Arduino Uno cable like this with the Arduino Uno. Then we are going to uploading the code. Now I have successfully uploaded the code here, and I have set up the sensors and the components as well. Now I'm going to turn on the switch. And keep remember, while uploading the code, you have to install some libraries, and we will mention in that code. Here you can see RoboXCraft temperature and humidity, and the temperature is showing 30.4 degrees Celsius and humidity is 60% out of 100%, and this temperature might not be 100% accurate. This is the project temperature and humidity measuring project.